Welcome back, Focus Learners. So glad you're joining us for another explainer. Let's just set the stage here, right? It's 2026. AI coding tools are literally everywhere. They're woven into almost every single workflow we have. But even with all this mind-blowing tech, engineering teams are slamming into a really persistent, incredibly frustrating roadblock. Their codebases are still suffering from massive architectural drift. Today, we're unpacking some brilliant source material from Emory HQ to figure out exactly why this keeps happening. Which brings us to a super urgent question. Why is your AI just totally ignoring your architecture and writing contradictory code? Now, you might be thinking, well, obviously I just need to give the AI more memory, right? But here's the harsh truth. Buying more memory tools is actually making this architectural drift so much worse. To wrap our heads around why, think of it like a library versus a judge. A library, fantastic. It'll hand you 10 books that might answer your question. A judge doesn't just hand you books. They listen to the facts, apply the law, and issue one binding ruling. And right now, engineering teams are buying libraries and wondering why they aren't getting any verdicts. Okay, let's dive into this. First, we're going to cover the big AI confusion. Then, what memory actually optimizes. Third, the governance difference. Fourth, memory feeds governance. And we'll wrap up with avoiding intent debt. All right, section 1, the big AI confusion. For a couple of years now, the AI coding space has essentially blurred 4 totally distinct systems into a giant puddle of buzzwords. So let's untangle them real quick. First up, we've got context. Context is simply the window of tokens that the AI model can see right at this exact moment. It's strictly a per-request property. Think of it as the immediate, temporary view for the model. The second that request is done, poof, that specific window is gone. Next is retrieval. This is just the mechanism or the index lookup that actually gets information pulled into that context window. It's the action of fetching the data. Basically, it's the forklift moving the boxes, not the warehouse itself. Then we have memory. Memory is the durable store of past interactions, decisions, and preferences that the retrieval mechanism reads from. We're seeing this everywhere with tools like Lutta, MemZero, or Clouds projects. And hey, they're incredibly good at storing data, keeping context between sessions, giving agents a sense of continuity. But, and this is a massive but, they do not enforce a single rule. Finally, we hit governance. Governance is the rule system that actually decides which architectural constraints apply to which code, and it strictly enforces them. Now, what's really interesting about this slide is that a governance system actually uses context, it uses retrieval, and it reads from memory. So because they're all tangled up together, governance looks at first glance like just another flavor of memory. But make no mistake, it is a fundamentally different beast built to do an entirely different job. Moving on to section 2, what memory actually optimizes. We really need to dismantle this total myth that memory is all you need. And the best way to do that is just to look at its optimization targets. Memory is built for recall under fuzziness. It actively wants to tolerate synonyms in your duplicates. Its whole goal is to return a ranked, top K list of results, and its output is proudly probabilistic. Remember our friendly librarian? You ask for a book on software architecture, they bring you 5 great options and say, hey, maybe one of these works. Now, that fuzziness is absolutely brilliant for answering customer support tickets, sure, but it is wildly dangerous when you're trying to apply strict architectural constraints to your codebase. Ultimately, memory systems optimize for recall. In a memory system, a false negative, like failing to find a relevant document, that is the main failure mode. If your database has, say, 5 overlapping, completely redundant documents about how to handle user authentication, memory doesn't care. To a memory system, redundancy is literally just a slight ranking nuisance. It's definitely not a system failure. All right, section 3, the governance difference. So if memory is the helpful librarian, governance is our highly analytical, no-nonsense judge. Look at the left side here. Memory leans heavily into fuzziness with top K probability. But on the right, governance is top 1. It is highly deterministic and focused purely on enforcement. A governance system can't just hand a coding agent 5 possible ways to write an API endpoint and shrug. No way. It has to output a single, resolved rule, top 1, and it must definitively reject any code that violates it, leaving an audit trail that explains exactly why. And this brilliantly illustrates a core philosophical difference between the two. In governance, conflict is the central case. Overlap is the entire point. Let's say you have an older architectural decision record, ADR 014, and a newer one, ADR 022.
and they totally conflict with each other. A memory system, it'll just rank them side by side based on keywords. A governance system, however, explicitly resolves that conflict. It looks at the specific file path, figures out which ADR has the narrower, more relevant scope, picks the actual winner, and enforces it.
Let's put them head to head here. Check out the target. Memory is for recall. Governance is for enforcement. Output, top K ranked versus top 1 resolved. The failure mode of memory is just a false negative, but the failure mode of governance is silent drift and contradictory diffs leaking straight into production. And look closely at the enforcement point. Memory just surfaces information and stops. Governance has a literal hook at the commit or pull request level. If you're buying a tool from that middle column, but you're expecting the behavior of the right column, you are practically guaranteeing that your codebase will silently drift into absolute chaos.
Section 4. Memory feeds governance. So how in the world do we fix this? Well, it's perfectly stated right here. Memory is an input to governance, not a substitute. Don't get me wrong, memory is absolutely crucial. I mean, you can't govern rules if you don't store them somewhere, right? But it sits exactly one layer below governance in the grand scheme of things. Let's move to and see how this builds a practical architecture. Step 1, the inputs layer, which includes your memory, retrieval, and context, does its thing by surfacing all the potential candidate rules. Step 2, the governance resolver steps up. It deterministically evaluates those candidates and figures out the exact precedence based on scope and priority. Step 3, the enforcement hook, steps in to inject the single rule before generation, or it checks it right at the PR boundary. And Step 4, the output is just one single resolved rule. This right here, this is the layer most teams are completely missing today.
Finally, Section 5, avoiding intent debt.
We really need to talk about the real-world impact this has on engineering teams. Like, why does this confusion persist in the market in the first place? Impartially speaking, it's not some sinister corporate plot. The primitives of these systems genuinely do overlap, as we've already seen. Plus, vendors are naturally incentivized to blur the lines a bit because they already have memory products ready to sell, and honestly, the market momentum is just huge right now. And frankly, buyers just don't have a sharp ask yet. They know they desperately want architectural consistency, but they don't quite know how to ask for governance instead of just saying, hey, give our agents more memory. And this whole confusion leads directly to something called intent debt. Intent debt is the gap between organizational decisions, those rules that live somewhere in a dusty wiki, and the actual constraints that your AI agents follow while they're generating code. Relying purely on memory leads AI native teams to accumulate massive amounts of this intent debt. You end up with a code base that looks like it was beautifully architected on the surface, but functionally, it behaves like it was just randomly sampled out of a hat. So, the crucial point is this. If you take away only one thing from today, please let it be this quote right here. Memory systems optimize recall. Governance systems optimize constraint enforcement. They are two completely, entirely different jobs. Trying to use one word to describe both is a very expensive mistake, and you'll end up paying for it in contradictory diffs and broken software. I want to leave you all with a little test question for the next time you're out there evaluating an AI coding tool. Go ahead and ask the vendor, what happens when two rules in your store totally disagree on the exact same file? If their answer mentions things like retrieval scores, vector embeddings, or chunking strategies, you are buying memory. But if they start talking about deterministic resolution and enforcement points, boom, you have finally found a governance system. Let's keep those architectures clean, focused learners. See you in the next explainer.